A step-by-step walkthrough of the Edexcel November 2018 Higher GCSE Maths Paper 2. Hey there guys, welcome back to the channel. If this is your first time here and you're trying to get the best grade in maths you possibly can, let me help. Start now by subscribing. Okay, before we get going, there are a few useful things linked in the description. First of all, the paper itself, so you can download and play along. My playlist with every Edexcel Higher paper walkthrough. My brand new formula booklet video is linked down below. In that video, I tell you how you can get a PDF copy. And I'll also link useful topic playlists that appear on this paper to help with your revision. Okay, let's do this. Number 1, Venn diagrams. So our universal set are the even numbers between 1 and 25. Set A contains 2, 8, 10 and 14. Set B is 6, 8 and 20. Set C is 8, 18, 20 and 22. Part A answers D. Complete the Venn diagram for this info. Okay, so 2 only pops up in A. Then we would have 4. 4 is in neither set A, B or C, so it just goes outside the circles. 6 is only in B. 8 is in A, B and C, so that's going to go in the middle. 10 is in A and only A, so 10 goes there. 12 is in none of the sets, so it just goes on the outside. 14 is in A and only A. Okay, that's all of the ones from A. So next is 16. It's in neither set. Next would be 18, so that is only in set C. 20 is in B and C, so that is going to go there. 22 is only in C, so that's going to go there. And then finally, 24 is in none of the sets. So it goes on the outside like that. Okay, and then part B tells us that a number is chosen at random from the universal set. Find the probability that the number is a member of A intersection B. So altogether we know there are 12 even numbers. So the bottom of the fraction is going to be 12. 12 even numbers in our universal set. And then A intersection B is everything in that overlap. So there's only one number in there, so the answer is 1/12. Okay, number 2. Sean has information about the height in centimetres and the weight in kilograms of each of 10 rugby players. He's asked to draw a scatter graph and a line of best fit. For this information, here is his answer. Sean has plotted the points correctly. We want to write down 2 things that are wrong with the graph. So the first one that hopefully is quite obvious is the line of best fit does not fit the data very well. It should be something more like that, maybe. So that would be the first thing we would say. Now the other thing took me a second to spot. It's down here on the scale of the height. So we go from 140 to 160 in one big square, but then the others go up in tens. So the scale is not consistent. So those are the 2 things wrong. Okay, number 3. Here is a triangle. We're told ABC and DEF are parallel lines, so we need to be thinking about angles between parallel lines. We want to work out the size of angle X. Give a reason for each stage of your working. Okay, so if we start down here, we know that this 110 degree angle and the 25 degree angle and the blue angle lie on a straight line, so they have to add together to 180. So 110 add 25 is 135. 180 minus 135 is 45 degrees. So it would be a good idea to write down some working and the reason doing this properly. Okay, so that's that angle. Can we do anything up here? Well, this is where the angles now between parallel lines come in handy. So this angle of 110 and this angle here are what we call co-interior. Co-interior angles add to 180. So this angle is 70 degrees. Now we have the same sort of situation, 3 angles on a straight line. So 70 add 35 is 105. That means then this angle has to be 75 degrees. Now we know 2 of the 3 angles inside a triangle. So angles inside a triangle must add to 180. So 45 add 75 is 120. So X has to be 60 degrees. Okay, number 4, we have compound interest, so I'll put my percentage increase and decrease playlist down below. So, Northern Bank has 2 types of account. Both accounts pay compound interest. The cash savings account pays 2.5% per annum, so per year, and the shares account pays 3.5% interest per year. We are told that Ellie invests £2,000 in the cash savings account. Ben invests £1,600 in the shares account. We want to work out who will get the most interest by the end of 3 years, and we must show all our working. Okay, so for Ali, to work out how much money she's going to have in the account after 2 years, we're going to do £2,000. Now we need to think about what the decimal multiplier is. So 2.5% is 0.025. So our multiplier is going to be 1.025. So we're going to multiply by 1.025. That would give us the amount in her account after 1 year. We want 3 years, so we stick a power of 3 on the multiplier. So that is going to give Ali £2,153. Pounds and 78p, which means that her interest is £153, 78p. Okay, then we're going to do the same for Ben. So for Ben, we're going to do 1,600. Now, his interest is 3.5%, so we're multiplying this by 1.035 to the power 3. And that gives us 1,773 pounds and 95p. So his interest is £173.95p. So Ben gets more interest. Cool. Okay, then for part B, we are told that in the 3rd year, the rate of interest for the shares account is changed to 4% per annum, so it's increased. Part B, does this affect who will get the most interest by the end of 3 years? Give a reason for your answer. So Ben had money in the shares account. Ben already got the most interest, so by increasing his interest in the 3rd year, it's not going to change our answer to part A. Ben will still get the most interest, he's just going to get even more. Okay, number 5. The diagram shows a floor in the shape of a trapezium. We are told John is going to paint the floor. Each 5 litre tin of paint costs £16.99. 1 litre of paint covers an area of 2 metres squared. So straight away, I would stop there. We can now say then that 1 tin covers 10 metres squared. Okay, and then next up, John has £160 to spend on paint. Has John got enough money to buy all the paint he needs? You must show how you get your answer. Okay, so the next thing we're going to need is the area of the floor. So, the area of a trapezium. Well, that worked well. There we go. Looks like that. So, it's the height times the top and bottom length, all divided by 2. So, the area of the floor then is going to be 7 times 10 and 16 all over 2. So remember to calculate paper, this should give you 91 meters squared. Okay, so if we then do 91 meters squared divided by the area one tin covers, so 91 divided by 10, it's going to give us 9.1. So that's how many tins are needed. So, John needs to buy 10 tins. So, each tin costs £16.99. So, 10 times £16.99 is £169.90p. John only has £160, so the answer is no. He does not have enough to buy the paint he needs. Number 6. A is the point with coordinates 5, 9. B is the point with coordinates D, 15. The gradient of the line AB is 3. Work out the value of D. Okay, so my equations of straight lines playlist will be down below, where we cover things like this. So, gradient is difference in y, so dy, over difference in x. So here we could do 15 minus 9 over d minus 5. So that is 6 over d minus 5. Now, we know then that has to be equal to 3. Now, 6 divided by 2 is 3, so this tells us d minus 5 has to equal 2. So, d is 7. 7a wants us to write the number 0.00008623 in standard form. So, we're going to need 8.623 times 10. Now the number is less than 1, so we're going to need a negative power, and that power is going to be 1, 2, 3, 4, 5. So it's times 10 to the minus 5. Okay, then part B. One says to work out 3.2 times 10 to the power 3, add 5.1 times 10 to the minus 2, all divided by 4.3 times 10 to the minus 4, giving your answer in standard form correct to 3 sig figs. So, put it into your calculator exactly how it looks, and the whole number we should get is 7441979. Now that written to 3 sig figs is 744 0 0 0 0. So that then in standard form is going to be 7.44 times 10. Now this time it's going to be a positive power, so it's going to be 1, 2, 3, 4, 5, 6. Okay, number 8, we have some transformations fun. So triangle P is reflected in the line y equals minus x to give triangle Q. Triangle Q is reflected in the line x equals minus 1 to give triangle R. We want to describe fully the single transformation that maps triangle R onto triangle P. Okay, so I've drawn in the two lines. So the red line is y equals minus x, and the purple line is x equals minus 1. So, first of all then, we need to reflect triangle P through the red line. So, let's do it point by point. This one is 1 diagonal square away, so it's going to reflect 1 diagonal square to the other side. This point is 1, 2, 3 diagonal squares away, so it goes 3 diagonal squares to the other side, and then this guy is 1, 2, 3, 4, so there's 4 on the other side, so that's going to be that. So this is triangle Q. Okay, and then triangle Q reflects through the purple line. So, the top point is 2 away on the left, so it's going to reflect 2 on the right. same as this point down here, and then the third one, it's going to be that. So this is terrible. Let's try that again. Okay, so that is triangle R. Now we want to know how can we transform that to give triangle P. So we can see it's going to be a rotation. Now with a rotation we need to know two other things. We need to know, well actually, three other things. We need to know in which direction and by how many degrees. So it's going to be 90 degrees anti-clockwise. And then we also need to know the point about which it's been rotated. So, a nice way to do this is to try and track a point as it goes around the rotation. So, this point here rotates up to there. If it carried on, it would rotate down to there. If it carried on, it would be down there. If it carried on, it would get back to where it started. The centre of that circle is the centre of rotation. So that is that point there, -1, 1. Okay, number 9, a bit of a strange one to see at GCSE level. So, Martin truncates the number n to 1 digit. When you truncate something, you cut off what you are not interested in. So, if he is truncating this number n to 1 digit, he's cutting off any decimal part. So the result is 7. We want to write down the error interval for n. So, as I said, very strange to see this at GCSE. In fact, I never have seen truncations. So, if he's cutting off the decimal part and his result is 7, then we know that n must be greater than or equal to 7. Now it must also be strictly less than 8. If it was 8.1, for example, and we truncated it to 1 digit, our answer would be 8. So that is our error interval. Okay, number 10, Robert makes 50 litres of green paint by mixing litres of yellow paint and litres of blue paint in the ratio 2 to 3. Straight away, let's write that down. So, 50 litres of yellow to blue in the ratio 2 to 5 is going to be, 2 to 3 is going to be 20 to 30. Okay, yellow paint is sold in 5 litre tins. Each tin of yellow paint costs £26. Blue paint is sold in 10 litre tins. Each tin of blue paint costs £48. Robert sells all the green paint he makes in 10-litre tins for £66.96 each. We want to work out Robert's percentage profit on each tin of green paint he sells. Okay, so let's work out how much he spends on paint first of all. So we're going to need 4 tins of yellow, so that's 4 times £26, that's £104. Now he's going to need blue paint is sold in 10-litre tins, he needs 30 litres, so we're going to need 3 blue. So that's going to be 3 times 48, which is 144. So from that we can get his total cost. So his total cost is £104 and £144, so £248. That's the cost to make 5 tins. From that then, we can work out the cost of 1 tin. So that's 248 divided by 5. That gives us £49.60. Now, profit is money that you make after making back what you've had to spend. So his profit on 1 tin is £66.96. Minus what 1 tin costs, so minus £49.60. Now that gives us £17 and 36p. So that's how much profit he makes per tin. Now to work out percentage profit, we do the profit divided by the cost multiplied by 100. So we're going to do percentage profit is 1736 over 49.60 times 100, and that gives us 35%. Number 11. In a restaurant there are 9 starters, 15 mains and 8 desserts. Jeanette is going to choose one of the following combinations for her meal. So, a starter and a main, or a main and a dessert, or a starter, a main and a dessert. We want to show that there are 1,335 different ways to choose the meal. Okay, so let's call these three A, B, and C. So for A, which is a starter and a main, we multiply the numbers of each together. So we have 9 starters, 15 mains, so that's 9 times 15, which is 135. Okay, then for option B, so here we want a main and a dessert, so that's going to be 15 times 8. So that's 120. And then for C, so one of each, we multiply all the numbers together. So 9 times 15 times 8. So that is going to give us a really big number, 1080. Now, if we add these three together, we do indeed get 1335. Number 12, algebraic fractions. So my playlist is below. So we want to share right 4x squared minus 9 over 6x, add 9 times 2x over x squared minus 3x in the form ax add b over cx add d, where a, b, c and d are all integers, so whole numbers. Okay, so the trick with algebraic fractions is always to, first of all, check whether we can factorise them at all. So 4x squared minus 9 is a difference of 2 squares. So we can write that as 2x add 3 times 2x minus 3. On the bottom, there's a common factor of 3. So we can write that as 3 lots of 2x add 3. So now the top and bottom of that fraction have a common factor. They're going to cancel, so that's nice. And in the second fraction, all three terms have a factor of x, so we can write that as 2 over x minus 3. Okay, so in this case, the 2x add 3's cancel out. So we have 2x minus 3 over 3 times 2 over x minus 3. So, when you multiply fractions, you just go across. So we have then 2 lots of 2x minus 3 all over 3 lots of x minus 3. Expand the brackets, and then we have 4x minus 6 over 3x minus 9. Okay, then for part B, we want to express 3 over x add 1 over x minus 2 minus 4 over x as a single fraction in its simplest form. So, classic maths, we don't want to do this all in one go. Let's first of all combine the first two. So the way to do this, I mean there are a few ways. Personally, I would use cross multiplication, but that might be a little bit scary. So go for common denominators. So the common denominator is going to be x add 1 times x minus 2. So for the first fraction, we need to multiply the top and bottom by x minus 2. So we get 3 lots of x minus 2 over x add 1 x minus 2, and then for the second fraction we need to multiply the top and bottom by x add 1. So we're going to get add x add 1 over x add 1 times x minus 2. Okay, now that they have the same bottom, we can just add across the top. So, if we expand those brackets on the first one, we have 3x minus 6. Then we have plus x, so we have 4x. And then we have minus 6 add 1, so that's minus 5. And that is all over x add 1 times x minus 2. So that is the first two fractions combined. So now we're going to subtract 4 over x. So now we have 4x minus 5 over x add 1 times x minus 2 minus 4 over x. Okay, so go for common denominators again. So we need to multiply the top and bottom of the first one by x. So we're going to get x times 4x minus 5 over x times x add 1 times x minus 2 minus 4 lots of x add 1 x minus 2. So we're multiplying top and bottom of this second one by x add 1 x minus 2. So then that's all over x times x add 1 times x minus 2. Okay, so now we need to expand So, if we do this first one, we get 4x squared minus 5x. Okay, now we're going to get minus 4 lots of, so let's expand those brackets. So x add 1 times x minus 2 is x squared minus x minus 2. And that is all over x times x add 1 times x minus 2. Okay, so if we now expand again, up on top we have 4x squared minus 5x minus 4x squared now we have minus 4 times minus x, so that's add 4x, and minus 4 times minus 2 gives us plus 8. All over x add 1 times x minus 2. So we can simplify the top. We have 4x squared minus 4x squared, so they cancel out. We then have minus 5x add 4x, so that's minus x. And then we have plus 8. So we have minus x plus 8 all over x add 1 times x minus 2. Good times. Okay, number 13, the diagram shows a circle and an equilateral triangle. One side of the equilateral triangle is a diameter of the circle. The circle has a circumference of 44 centimeters. We want to work out the area of the triangle. Give your answer correct to 3 sig figs. Okay, so given that we know the circumference of the circle, we can work out the diameter, which is the side of the triangle. So circumference is pi times diameter. So that tells us then the diameter is 44 divided by pi. Now that gives us 14.00, so we're just going to call that 14. Okay, so at this point we can now forget the circle. We now have this equilateral triangle with sides of 14 centimeters. Now we could use Pythagoras to find the height and work out the area that way, or we can use area of a triangle with trigonometry. So we know, given that we are in an equilateral, the angles are all 60 degrees. So we need an angle and the two sides coming out of that angle. They're both 14. So the area is 1/2 times 14 times 14 sine of 60. Okay, so put that in your calculator and we should get 84.87 centimeters squared, but we want that to 3 sig figs, so it's going to be 84.9. Okay, number 14, an exponential curve. So on the grid, sketch the curve with equation y equals 2 to the power x. And we want to give the coordinates of any points of intersection with the axes. Okay, so exponential graphs pretty much all look the same. They look like that, so they never touch the x-axis. The y-intercept happens when x is equal to 0, so 2 to the power 0 is 1, so the coordinates here are 0, 1. Okay, number 15, the equation of a circle is x squared and y squared equals 42.25. We want to find the radius of the circle. So, equations of circles are in my booklet. Circles centered at 0, 0 have equation x squared and y squared is equal to the radius squared. So, here, r squared is 42.25. So r is the square root of 42.25, which is 6.5. Okay, number 16, we are told there are only red counters and blue counters in a bag. So takes a random counter from the bag. The probability that the counter is red is 0.65. So puts the counter back into the bag. Okay, so at this point, I'm going to write down the probability of red is 0.65. Well, that means the probability of blue is 0.35. Okay, back to the story. So then Mary takes a random counter from the bag. She puts the counter back in the bag. Part A. What is the probability that Joe and Mary take counters of different colours? Okay. So, there's two possibilities here. Either Joe takes a red and then Mary takes a blue, or Joe takes a blue and Mary takes a red. So, if we do probability of red then blue, that's 0.65 times 0.35, and that gives us 0.2755. Or we can do the probability of blue and then red. So that's actually going to be exactly the same, because it's 0.35 times 0.65. So again, that's 0.2755. So we then add these two together and we get 0.455. Okay, then for part B, we are told there are 78 red counters in the bag, and we want to work out how many blue counters are in the bag. Okay, so this is now reverse percentages. We know the probability of getting a red is 0.65, so 65% are red. So that means 65% of the total counters in the bag are red. What we need to do is work out what 35% would be. So, we know then 65% is 78. So, we could go for finding the total amount of counters in the bag, subtracting the number of red, doing it that way, or we could try and turn 65% into 35%. So, to do that, we need to try and think of a nice percentage that fits into 65 and 35%. So that would be 5%. So to turn 65 into 5, we have divided by 13. So we do that 78 2. Now 78 divided by 13 is 6. So we can then turn 5% into 35% by multiplying by 7. So 35% is equal to 42. Number 17, so a really nice looking 5-mark ratio question, which I think is also going to need simultaneous equations. So, P and Q are two numbers such that P is greater than Q. When you subtract 5 from P and subtract 5 from Q, the answers are in the ratio 5 to 1. Okay, let's write that down. So, P minus 5 to Q minus 5 are in the ratio 5 to 1. Okay, and then we're told when you add 20 to P and add 20 to Q, the answers are in the ratio 5 to 2. So, P at 20 to Q add 20 is in the ratio 5 to 2. Good times. Okay, so we want to find the ratio P to Q. Giving our answer in its simplest form. So you might be thinking here, can't we just either add 5 to both sides of the ratio on the left, or subtract 20 on the right? The answer is no. With ratios, you can only multiply or divide both sides by the same thing. So what we're going to need to do is use each ratio to get an equation. So, starting on the left. So, looking at these two numbers, we think about, well, what is the biggest number, the smallest number that 5 and 1 both go into? So as it happens, it's 5. So, we only need to multiply 5 by 1 to get 5. So we're going to need one lot of P minus 5. Now, to turn 1 into 5, we need to multiply it by 5. So P minus 5 is equal to 5. Lots of Q minus 5. So, we can say that P minus 5 is equal to 5Q minus 25. So from that we can actually get P on its own, so we can know what P is in terms of Q. So P is equal to 5Q minus 20. Okay, so now that we know what P is in terms of Q, we can rewrite this ratio up here. So, we know that P is 5Q minus 20. So, the left-hand side of this ratio now is just 5Q. So we now have 5Q to Q add 20 is in the ratio 5 to 2. So, we're going to do again what we just did on the left. We're now going to turn this into an equation. So, the first number 5 and 2 both go into is 10. 5 goes into 10 twice, so we multiply 5Q by 2. So we get 10Q. And on the right, we need to multiply 2 by 5. So we get 5Q add 100. Okay, so now we need to solve this for Q. So subtract 5Q, we get 5Q is 100. So Q is 20. Now, from that, we can now work out what P is. P, again, is 5Q minus 20. So, P is 5 times 20 minus 20, which is 80. So, P to Q are in the ratio then 80 to 20. There's a common factor of 20, so it's 4 to 1. Horrible question. Okay, number 18, more straight line fun. So again, my playlist is down below. So the straight line L1 passes through the points with coordinates 4, 6 and 12, 2. The line L2 passes through the origin, so 0, 0, and has gradient minus 3. The lines L1 and L2 intersect, so meet at point P. We want to find the coordinates of P. Okay, so what we need to do is find the equations of both lines and then solve them simultaneously. So, let's do L1 first. So, the general equation of a straight line is y equals mx add c. Now, m is the gradient, c is the y-intercept. So, we need to first of all find the gradient. So, gradient is difference in y over difference in x. So, if we do 2 minus 6, we then have to do 12 minus 4 on the bottom. Okay, swap on top, we get minus 4. On the bottom, we get 8. So, our gradient then is minus 1/2. Okay, so now for L1, we know y is minus 1/2 x. And c. Now to find the value of c, we substitute in one of the pairs of coordinates. So I'm going to use 4, 6. So when x is 4, y is 6. So we get 6 is equal to minus 2 add c. So c is 8. So L1 has coordinates, no it doesn't, it has equation y is equal to minus 1/2 x add 8. Okay, now then, there's good news. L2 is much simpler. So L2 passes through the origin, 0, 0, so c is equal to 0, and its gradient is minus 3. So L2 is just y equals minus 3x. Okay, so there are the two simultaneous equations. So given that both of them are telling us what y is equal to, we can actually just set them equal to each other. So, because y is minus 1/2 x, add it, and y is minus 3x, this tells us minus 3x is equal to minus 1/2 x, add 8. So, from this, we can find the value of x. So, if we add 3x to both sides, probably the nicer way to do it, then we're going to get 2.5x, or 5/2 x. So we're going to get 0 is equal to 5/2 x. Add 8. Subtract the 8. We get minus 8 is 5/2 x. Multiply by 2, minus 16 is equal to 5x. Divide by 5, we get x is minus 3.2. Okay, so now that we know what x is, we can find y. Remember, y is minus 3x. So, y is minus 3 times minus 3.2, which is minus 9.6. No, it's not. It's positive 9.6. So, the coordinates are minus 3.2, 9.6. Okay, number 19, we have quadratic inequalities on steroids. So, we want to solve m squared add 7 over 4 is greater than 22 and less than 32. Shall we work it? Alright then, we will. So, first thing we need to do is get m squared on its own in the middle. So, we're going to multiply through by 4. So we're going to get 88 is less than m squared add 7 is less than 128. Okay, next we're going to subtract the 7. So that's going to give us 81 is less than m squared, which is less than 121. Now, we do have two square numbers here on the left and right. So you might think, oh, now we can just square root and be done. We can't though, because when you square root, you get positives and negatives. So we now need to think about the graph. So we want the region where y equals m squared is between, well, the y value is between 81 and 121. 21. So, if we plot y equals m squared, so let's say 81 is there, and 121 is up there. So, what we're interested in are the values of m that make these two parts of the graph. So, what we need to do then is find the m values down here. So, this guy would be the negative square root of 81, so that's minus 9. And this one would be the negative square root of 121, which is minus 11. So, that gives us an answer. We want m values between minus 11 and minus 9. So, one solution is m is strictly greater than minus 11, but strictly less than minus 9. Now the other solution is over here, so that m value would be the positive square root of 81, which is 9, and this is the positive square root of 121, so that's 11. So the other solution is that m is strictly greater than 9 and strictly less than 11. So those are our two solutions. Okay, number 20, look at this, data list. So we got a frustum of a cone. That means if you have a big cone, lop off a little cone, you're left with a frustum. So the diagram shows that the frustum is made by removing a cone with a height of 3.2 centimeters from a solid cone with a height of 6.4 centimeters and base diameter 7.2 centimeters. Okay, we're told the frustum is joined to a solid hemisphere of diameter 7.2 centimeters to form the solid S shown below. Times, so the density of the frustum is 2.4 grams per centimeter cubed. The density of the hemisphere is 4.8 grams per centimeter cubed. We want to calculate the average density of solid S. So, before anyone says, no, we can't just add the densities together and divide by 2. What we're going to need to do is work out the, density is mass divided by volume. So we are going to need to work out the total mass of S and the total volume of S. So we are going to do the frustum first of all. So to work out the volume of the frustum, we're going to need to work out the volume of the big cone first of all. So the volume then of the big cone. So we're given the formula, it's 1/3 pi r squared h. So we have a diameter 7.2, our radius then is 3.6. So this is going to be 1/3 times pi times 3.6 squared times the height, which is 6.4. Okay, now that is going to give us 86.9 centimeters cubed. Okay, now we need the volume of the small cone. Okay, so again it's going to be 1/3 times pi. What's the radius though? Well, because we're cutting this cone halfway up, the radius is going to be half of the big cone. So the radius is going to be 1.8. So we have 1/3 times pi times 1.8 squared, and the height is 3.2. So that gives us, drop my board. Okay, so that gives us 10.9 centimeters cubed. Okay, so we can now work out the volume of the frustum. So that is going to be 86.9 minus 10.9, so that gives us 76 centimeters cubed. Okay, so we're going to need that again. From that, we can also work out the mass of the frustum. So, density is mass divided by volume. Mass is density times volume. So, 76 times 2.4 gives us 182.4 grams. Okay, so we're going to need that too. Alright, so now we need to do the same thing with the hemisphere. Okay then, so for the hemisphere is half a sphere, so the volume is 2/3 pi r cubed. So the volume of the hemisphere is 2/3 times pi times the radius cubed. So again, the radius is 3.6. Okay, so that gives us a volume of 97.7 centimeters cubed. Okay, so let's start writing these things next to each other. So the volume of the frustum was 76 centimeters cubed. Okay, so now then we also need the mass of the hemisphere. So again, mass is density times volume. So the density of the hemisphere is 4.8 grams per centimeter cubed. So the volume, the mass of the hemisphere is 4.8 times 97.7, which gives us 469 grams. Okay, now let's also write the mass of the frustum. So that was 182.4. So we can now finally finish with past it. So the total mass is these two numbers added together, so we get 651.4. So that's grams. Total volume that's these two numbers added together. So for that we should get 175.7. That's centimeters cubed. So then the density is 651.4 grams divided by 175.7 centimeters cubed, which, if we go to two decimal places, we get 3.71 grams per centimeter cubed. You're allowed answers anywhere from 3.7 to 3.8. It all depends on your rounding. Question done. That's exactly why I hate calculator papers. Okay, number 21, the final question. So a pretty horrible circle theorems question. My playlist is down below. So, A, B, R and P are 4 points on a circle with centre O. A, O, R and C are 4 points on a different circle. The two circles intersect at the points A and R. We're told CPA, CRB and AOB are straight lines, so we have a triangle. We want to prove that angle CAB is equal to angle ABC. So, angle CAB is this guy up here. Angle ABC is this guy down here. Now the way that we're going to do this is by making a cyclic quadrilateral inside the left-hand circle. Now the way that we're going to do that is by joining up point O and point R. So, in cyclic quadrilaterals, opposite angles add up to 180 degrees. So, if we call angle CAB, let's call it X, and then by the cyclic quadrilateral theorem, we know this angle down here, well, that and angle X need to add up to 180, so this angle is 180 minus X. Okay, then next step, we now have angles on a straight line. Now, angles on a straight line add up to 180 degrees. So, this angle has to be angle X. Now, we are inside a triangle. Now, these two sides are both a radius of the circle. So it's an isosceles triangle, so this angle, the green angle, also has to be X, which is the same as angle CAB. So we've shown it. Probably a good idea to have got some words down to answer this properly, but that's how we would do it. Alright then guys, that's that paper done. So again, I would say that was really horrible. Maybe paper 3 is the nice guy. Don't forget, if you found this useful, give us a thumbs up, get subscribed, drop us a comment down below with any requests, share with your friends because they may need help too. Take it easy, take care.